All right, in this lesson, I'm going to introduce a few characteristics of a sinusoidal function. So before I do that, I want to actually go through this term, sinusoidal function. A sinusoidal function includes two different functions here. So y is equal to sine x, okay, and y is equal to cos x. And these two functions are called sinusoidal functions because they follow the same pattern, which we have referred to as a sine wave. So any graph that follows any type of sine wave is going to be considered a sinusoidal function. Okay, so we're going to take a look at a sinusoidal function, the graph of y is equal to sine x. So I'll erase this here. And so we're going to define a few characteristics. The first characteristic I want to define for you is what we call the horizontal midline axis, or just the midline. And that is defined as the line halfway between the max and your min values. So if we're taking a look at the graph of y is equal to sine x, my max value is right at positive 1, and our min value is at negative 1. So the line, the midline axis, is going to be that line that goes right in between those two values. And the line that goes right in between those two y values is located right along your x-axis. So the midline for this specific graph is going to be y is equal to 0. Now, it's not going to be the case for every single sine graph that you'll see. So a general formula to help you find the midline is given as follows. Y is equal to your max plus your min divided by 2. So you're essentially taking the average of your max and your min values. And that's going to give you the line of your midline axes. So if I use this formula to find the midline axes for this specific graph, we take a look at the max and min values. So my max value is positive 1. My min value is going to be right at negative 1. Okay, and this is going to be all over 2. 1 plus negative 1 is going to give you 0. So 0 over 2 is going to give you 0. So that confirms this y is equal to 0 line. Okay, so keep in mind this formula, put it in your notes. It's really, really helpful when you're trying to find the midline axes, especially when your graph gets a little bit larger. So the next characteristic I want to define for you is what we call the amplitude. And the amplitude is defined as the vertical distance from the midline to the max or min value. So I'm going to just erase these markings here. This is what your amplitude is going to look like. You're going to start from the midline axis, which we have found was y is equal to 0, which is also the x-axis. And that is going to help us find the amplitude. It's going to be the vertical distance between that blue line and whatever your max or min value is. So this distance here and this distance here, okay? If we keep going, these are all our amplitudes here. And remember, it's a distance, so we're talking about a positive value here, okay? So amplitude is going to be positive. So in this case, my amplitude is going to be 1, okay? So we'll say amplitude is equal to 1. Okay, so just like in my horizontal midline axis description, there is actually a really, really simple formula to help you find the amplitude if your values are too big to actually identify it. And that formula is going to be as follows. Amplitude is going to be equal to, erase that 1, max minus your min over 2. And once again, that's just a handy formula when your values get too big. So your max in this case is 1, your min is negative 1, so you're subtracting a negative 1, and you're going to get 2 over 2, which gives you an amplitude of just 1, which is what we got before when we read off our graph. Okay, so you can read off your graph to find your amplitude, or you can use this really, really handy formula here. Okay, and so next we want to define our domain and range. Once again, we know that this graph extends outwards towards positive and negative infinity. It's a continuous graph. There are no breaks or points of discontinuity. So that means my x values are all defined. So we'll say x is a member of the reals. Now, our range is not going to be the same case here. We have a max value of 1 and a min value of negative 1, so we don't go past those points. So we can conclude that the range is going to be greater or equal to negative 1, but less than or equal to positive 1. Okay, so keep that in mind for your sine waves, that your y values are going to be restricted. Okay, and that all depends on what your max and min values are going to be. So the last thing I wanted to define here is what we call the period. And the period is what we call, is what we define as the length of the shortest repeating section. So yes, we do have a pattern here, and that pattern is repeating, okay? But the period is defined more specifically as the shortest repeating section. Okay, so an easy way to identify the period is to start at a point. So I'll start right there at the origin, and you're going to trace when does this graph start to repeat itself. So we are what we call rising through that point. So we're going up, okay? So we want to trace along this graph. When does it start to rise again? We're going down, we're going down, we're going down, we're going down, and right at that point right there, we start rising. Okay, so we can conclude that the shortest distance a repetition is going to be 360 degrees for this specific graph. So the period of the sine wave is 360. Okay, and also if you're working with radians, it's simply going to be stated as 2 pi. So that concludes my lesson on the characteristics of a sinusoidal function.